Okay, in this video we're going to do a little bit of a brief overview of a couple of different integration techniques or types of integrals we'd run into. So the first one there is if you have the integral of a constant k dx, the integral of that will be kx plus a constant of integration. The second one there, you have the integral of x to the n dx, that's going to be your power rule. So you're going to add 1 to the exponent, make that n plus 1, and then divide by that exponent n plus 1, plus constant of integration. And of course this is only when n is not negative 1. If n is equal to negative 1, then we're looking at the integral of 1 over x dx, which is equal to the natural log of the absolute value of x plus constant of integration. One of the easiest integrals or derivatives is the integral of e to the x is e to the x plus c. And then for our u substitution, here you have u equals g of x, du would be equal to g prime of x dx. So it's looks a lot like part of the chain rule. So we're just doing the chain rule backwards here, and that's our u substitution. So that's a skill that we definitely need for integration in Cal 2. All right, so let's go ahead and work out some examples. We'll speed up the instructions. Integrate the definite or indefinite integrals. So remember, the definite integrals will have limits of integration, indefinite will not. So we're going to look at the integral of 5 dx, so that's a constant, so that will be 5x plus the constant of integration. That's it. And you can always check by taking the derivative. So if you take the derivative and you get back to the original integrand, then you have successfully found the integral, or the antiderivative. Okay, let's take a look at the integral of 2x cubed plus 5 over x squared minus sine x minus cosine x dx. So you may also want to review the antiderivatives of the trig functions. We'll go ahead and rewrite this. 2x cubed plus 5 times x to the minus 2 minus sine x minus cosine x dx. Okay, so the first term we're going to apply the power rule. So we're going to add 1 to the exponent. So it'll be x to the 4th and then divide by the 4. Okay, add 1 to the exponent. So that'll be to the negative 1 power and divide by negative 1. The integral of sine of minus sine will be cosine, and the antiderivative of minus cosine will be minus sine. Don't forget your constant of integration, and we can rewrite that as 1/2 x to the 4th minus 5 over x plus cosine x minus sine x and plus constant of integration. And remember, if we start with sine, a derivative of sine is cosine. Derivative of cosine is minus sine. Derivative of minus sine is minus cosine. And if we're integrating, we're going to go up. So to go from integrate minus sine, that'll be cosine. And then to integrate minus cosine, that is minus sine. If you want to take derivatives, derivative of sine is cosine. And this pattern will continue. So a cycle of 4 before it's going to repeat itself. All right, a couple more examples. So we got the integral of 5 over x plus sine of 5x dx. All right, so that is going to be, so we got that 1 over x, so that's going to be the natural log. So we'll have 5 natural log of the absolute value of x. Over here we can separately do the integral of sine of 5x dx. Okay. Now, if we were taking the derivative, you would get cosine 5x times 5 by the chain rule. So instead of multiplying by 5, you're going to divide by 5. We can illustrate that using a little bit of u substitution. So u is equal to 5x. du is equal to 5 dx. Okay. So we don't have a 5 in the integrand. So what we can do is we can go ahead and put a 5 here. And then to offset that, we'll go ahead and divide by 5. So this is equal to 1/5 integral of the sine of u du. So there's your u, and your du is going to be 5 dx. So what's going to remain is you're going to have a u inside the sine and then a du. So integral of sine is going to be a minus cosine of u plus constant integration. And so that's where we get the negative cosine of 5x over 5 plus your constant integration. All right. So let's take a look at another example here. Let's do the integral of 1 over 3x minus 7 dx. This is also a u substitution. And the degree of the polynomial down here is 1. So this is probably going to be a natural log. We'll go ahead and perform u substitution. So u is equal to 3x minus 7. Du is equal to 3 dx. Okay? So here's our u. The du needs a 3. We don't have a 3. So what we'll have to do is we'll have to put a 3 in there and then offset that 3 by dividing by 3. And so this becomes 1/3 the integral of du over u, and that's going to be 1/3 natural log absolute value of u plus the constant of integration, and replace that u with what it was equal to, which is 3x minus 7. Okay, and we'll take a look at one more. Integral of e to the sine of x cosine of x dx. Nice straightforward u substitution. So we got to know that derivative of sine is cosine. U is sine x. Du is equal to cosine x dx. So this is equal to the integral of e to the u du. Integral of e to the u is e to the u plus c. And then we can go ahead and replace the u with the sine of x. Okay. All right. I think we got a couple more. So how about secant squared x over the tangent of x dx? And so if I realize that if I notice that the derivative of tangent is secant squared, there's my u substitution right there. U is tangent of x. Du is equal to secant squared of x dx. Nice clean substitution. So that's the integral of du over u, which is equal to the natural log absolute value of u plus c, and replace that u with the tangent of x. All right. How about the integral of negative 3x squared x cubed dx? Okay. So again, you're thinking, oh, the derivative of x cubed, that's 3x squared. There's our u substitution. U is equal to x cubed, du 3x squared dx. We don't have the negative there. That's okay. You can shuffle that out of the integral if you'd like. So we can slide that right on down. Okay, so there it is. And we got 3 to the u du, which integrates to negative e to the u plus c, and replace the u with the x cubed. Okay. Two more. I think two more. What do we got next? Number 35. Oh, maybe it's one more. Okay, so I got 6x plus 5 over x plus 1. And, sometimes we'll want to know, so when do I do like a long or like a synthetic division? And that's when the degree of the rationals top and bottom is the same. So this is degree 1 and this is degree 1. So if the degrees are the same, you want to do a long division or synthetic division. Or if the degree of the top is larger for a rational, that's usually when you want to do that long division. So we're going to go ahead and perform that long division. So x plus 1 into 6x plus 5. X times 6 is 6x. 1 times 6 is 6. And then we'll subtract, and that's going to give us a remainder of negative 1. So our quotient is 6 plus a remainder of negative 1 over the divisor, okay? All right, so the integral of 6 is 6x, and then minus the natural log absolute value of x plus 1, plus your constant of integration. If you needed a little bit of extra steps there, 1 over x plus 1 dx. U is x plus 1. Du is dx. So this would become the integral of du over u, which would become natural log absolute value of u plus c, and then you can replace the u with what it was equal to, which was x plus 1. Okay? All right, so that's it. Real short review, a couple of different types of integrals we'll run into. This is not an exhaustive list. Just kind of get your feet wet with what you can see out there as a little bit of a refresher, and then you just need to go in there and practice in the homework. All right, so we'll see you next time.